A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good day to all the juries and the participants of 4th Putrajaya International Conference on Multidisciplinary Research 2022. On this lovely day, I would like to present my article with title Numerical Study of Shrouded Diffuser Wind Turbine. Before I go further on my presentation, I would like to introduce myself. My name is Ainaa Munira binti Ismail. I'm from School of Mechanical Engineering, Faculty of Engineering, University of Technology, Mara, and also student in UTM Skudai. My outline of presentation consists of introduction, which has objective and background information or literature review. Next, we have methodology, data analysis, conclusions. First, we go to the introduction. Renewable energy sources include the sun, wind, wave, rain, and others such as tides and geothermal heat. Since wind turbine is the most promising renewable alternative, a policy has been created to ensure that its role in energy resources is increased. So, it is believed that wind power is extensively assumed to be equal to wind speed as wind blows toward a wind turbine. There is two types of wind turbine depending on their axis, which is horizontal axis wind turbine and vertical axis wind turbine. Wind turbine has various sizes by depending on its applications. Small wind turbine can be used as distributed generation for on-site application, while larger wind turbine are used in wind farms. The objective of this article is to maximize the physical properties of the shrouded diffuser through research on flow characteristics. Therefore, the background information or literature review will be based on small wind turbines and shrouded diffuser wind turbine. Background of study for small wind turbine consists of small wind turbine offer a significant amount of alternative power for electrical devices. A proper small turbine design is also important to consider because it can affect efficiency and energy capture. Usually, small wind turbines installed on parks, suburban homes, or other locations where there is no electrical grid or where the grid has sustainability issues. Electricity output should be as sustainable as possible for off-grid application. Next, background information or literature review for shrouded diffuser wind turbine consists of innovation to improve wind turbine performance have resulted in the use of ducts around the rotor to augment flow. A diffuser can improve wind turbine performance by increasing power efficiency, and wind turbine with diffuser capable to boost up the mass flow rate through the rotor lead to produce more power. Based on the literature, CFD can be used as a potential tool to study the detail of flow field around wind turbine rotor. Therefore, ANSYS Fluent in CFD package is employed to obtain the outcome of flow characteristic of bare and shrouded straight diffuser. Methodology for this numerical study consists of modeling by using SolidWorks software. Then, import to CFD ANSYS Fluent for meshing processing. Then computational model validation by using solver tests. On CFD simulation, the parameters used are turbulent model KWSSD, which is K omega SSD, pressure discretization, which is semi-implicit method, pressure link equation, simple, and the boundary condition with various inlet velocity in range 1 to 15 meter per second. So the discussion is velocity distribution, velocity vector, kinetic turbulent energy, lastly, average velocity and power output. For the result and discussion, we go through first velocity distribution. The finding demonstrates that the velocity relatively increases at the turbine rotor of a wind turbine with a straight diffuser. Due to the inlet shrouded convergence profile, there is an augment in rotor velocity. A notable increase in wake formation behind the diffuser has been noticed, creating a low pressure area behind the turbine. The top of the turbine is increased because of the low pressure area bringing more air to strike the rotor as illustrated in figure. Next, we go to the velocity vector. The recirculating flow at the shrouded of the straight diffuser wind turbine is observed, causing a turbulent flow field, which is not present in the baseline model. By review in figure, the velocity vector captured around the outlet shrouded surface also clearly shows which is larger in magnitude. Next, we go to the turbulent kinetic energy. The variation in turbulent kinetic energy along the wind turbine can be reviewed in figure. The term turbulent kinetic energy is basically referring to turbulent intensity. Wake formation has been observed as a result of increased turbulence at the shrouded straight diffuser compared to the bare wind turbine. A wake region is clearly seen at the shrouded region of the straight diffuser. The area with the highest intensity of turbulence is found downstream from the diffuser and has an asymmetric flow pattern. Last, we go to the power output. The power output for both wind turbine can be seen in figure. The wind turbine equipped with shrouded straight diffuser is significantly higher, roughly double than power coefficient compared to the bare wind turbine. The conclusion of this article are: the shrouded straight diffuser wind turbine boosts the velocity of air at the turbine rotor. As a result, the velocity increased yield of intensification wind turbine power. Hence, when compared to the bare wind turbine, the shrouded straight diffuser model typically can produce about 23.17% more power. Thus, CFD analysis produce better outcomes than potentially prohibitively expensive experiment testing. Thank you for your time and feel free to scan the article.